Let's continue on working with geometric probability. So this lesson will also be on I can find geometric probability. And just as a reminder, geometric probability is where we find success and we put it over the total amount and we get a number between 0 and 1. We're going to list those answers either as decimals or as fractions. In this lesson, I'm going to list the answers as fractions. So we're going to look at, first of all, what we would call spinor problems, and then we'll look at number line problems. First of all, the spinor problems are ones where if you had a spinner on this and you were to spin it and it were to land randomly in one of these areas, red, green, blue, or black, what would be the probability it would land in a certain one of these regions? So let's start off with, as a reminder, when we talk about circles, a full circle all the way around is 360 degrees. So when we talk about the total for it, and you're thinking about these spinor problems, you're going to put the number over 360 because that's the total number of degrees in the whole circle. What you're going to do then is you're going to take whatever the angle is that you're working with and put it over 360 to get the success. So that's kind of the key idea for doing this type of problem. All right, so first of all, let's start with probability here of doing red. What that would equal then is red is 120 degrees. We'd put that over the total number of degrees in a circle is 360. So 120 over 360 reduces down to 1/3, so my probability is 1/3. So that's how you do that type of problem. Now, I'm going to throw a little extra into this one. In this one, I want to put in the word or. I want the probability it lands in either green or black. Well, think about the word or. That means you're going to add them together. Okay, now why that is because it could either be in green or black. Both of them is success. So when we do our fraction, you're going to say green is 60 degrees, black is 72 degrees. So we're going to add those together and put it over our total, which is 360. So we take 60 plus 72 and we get 132 over 360. And if we were to reduce that fraction down to its final form, we would get 11 over 30 in reduced form. Okay? Now, one more different type of problem. What if we said, what's the probability it would not land on red? So we want anything except for the red. There's two ways to go about this. You could either say, I'm going to add up all of these, which I'm going to start off by doing 60 plus 108 plus 72, everything that's not red. So 60 plus 108 plus 72, put that all over my total, which is 360. Add those together, and I get 240 over 360. Which then reduces down to 2/3. Another way to do that, though, you could do this as well. If it's not red, remember total. If the total amount is successful, the total amount here over the total would give me 1. So the largest probability could be is 1. So I could take 1 and subtract what the red probability is. And that would also get me 2/3. So you can do it with 1 minus the amount it is if it says not that value or that color. All right, let's try the next part. Okay, to do this next section, what we have is we have a number line here. I'm going to represent this number line with numbers. So from P to Q, it's 7. From Q to R, it's 13, and from R to S, it's 5. Now what we want to do is find out what's the probability if a point lands on this, that it's going to land on RS, which is this segment over here. So that success is 5 of the whole value, and the total from here all the way from P all the way to S, if I add up those, I get 25. So my 5 over 25 would reduce down to 1/5 for an answer. Okay, now let's try, again, a twist on it. Let's say, what if it's not going to land on QR, this middle part? Well, I've got two ways to do it. I can either add the other two together and put it over the total, which is what I'm going to do. I'm going to put 7 plus 5. What are successful, that's the success over the total, which is 25. And so you get 12 over 25 as our answer there. Okay. Now you could also do, if you wanted to, 1 minus whatever QR is, because you want it to be everything except that. And if you do 1 minus 13 over 25, you actually get 12 over 25. So you can do it either way. Now let's lastly do this last one, probability on PQ or QR. Now remember, the word or here means you're going to add them together. So notice the PQ or the QR would give me 7 plus the 13 over the total, which is 25 all the way across. That gives me 20 over 25, which would reduce down to 4/5 as my answer. So in our first lesson, we talked about how to do geometric probability with areas. Now there's two other types that we've talked through. What if we have this kind of spinner problem where you take the angle over 360, whatever success is, that angle, you put it over 360 because that's a full circle, and that will get you your geometric probability. Or the other type of problem is a number line type of problem where you're given values for it. On this problem also, it could be listed with number lines. Like if I went ahead and labeled this off and this were 0 and I went 1, 2, 3, 4, 5, 6, 7, I could label it with a number line and do the rest of it that way too. The only difference there is you would have to count values to see how much it is between the dots. Okay? Those two different types of probabilities, the things to add into it, if we have an or, we add them together. If it's a not or a no, then what you do is you either add the other ones that aren't that one, or you take 1 minus it to get the answer. And that's how we figure out our geometric probability.